Welcome. This is the first of a series of videos that we're doing about smart electric hydrofoils. And it's my pleasure today to interview Michael Eaglen from EV Maritime in Auckland, New Zealand. Welcome, everyone. Michael Eaglen from EV Maritime is here, and we're going to have a little chat about smart electric hydrofoils and their particular version of that, the EVM 200. Michael, you've got a background in luxury super yachts, and I did wonder, what made you move from luxury super yachts, which I imagine is still quite a profitable and nice area to be in, to an area like electric ferries?
Oh, well, I've got a background in lots of things, actually. Super yachts was the last of those things, I guess, before I moved into commercial boats. Ultimately, I much prefer it. I don't like super yachts. I like the inherent sustainability of the business sustainability of doing boats that people need rather than boats that people only want. I like the environmental and social sustainability of building boats that really matter and that make a difference to the world. So yeah, I couldn't be happier.
And what does EV Maritime offer ferry operators? What makes you guys stand out? What's your kind of, I guess, the elevator pitch?
Well, look, I mean, we're a clean tech marine design, engineering, and technology company. Our mission in life is to decarbonize the harbour cities of the world. And for us, that's, as a technology company and as a set of engineers and naval architects, that's about designing and developing and delivering the boats which will transform our cities into being better places. In marine electrification, of course, there's a huge trend, a huge movement worldwide. And in finding our own place in that, I guess we went looking at where we had particular skills as a group of people and as a New Zealand industry, and in the places where we could make the biggest contribution at this stage. And ferries is a really logical place for that, for a whole raft of reasons. And so yeah, we develop electric fast ferries. We design them. We partner with boat builders around the world to enable public transport agencies and operators to buy from their local builders, and we support those projects through that, and help make sure that electric ferry deployments are successful, both from a safety and public transport perspective and reliability perspective, but also from an economic and practical and operational perspective, because we think ultimately that's what's important to transforming our cities by electrifying public transport, growing public transport, growing the role of cities and the role of ferries in our cities. So that's the kind of broad context that we work in.
Yeah. I really appreciate the idea that sustainability has got to come out of good business. It's got to make sense economically for people to do stuff for it to happen.
Well, I mean, it doesn't have to, but it's an awful lot easier. I mean, I think that, there's a lot of people who say, well, a lot of people who expect the electric future to be a whole lot cheaper than the diesel future, and it may or may not prove to be. But the point is, the diesel future is not an acceptable future. So, nevertheless, it's an awful lot easier for everybody if an electric boat, which is always going to cost more in the first place to buy, but always cost less to operate. It's an awful lot easier if the economics stack up. So we certainly do put a lot of effort into making sure they stack up. But it's a multi-pronged thing. It's not only energy use, it's repairs and maintenance, it's improving reliability, it's enhancing longevity of the boats, it's across all areas of it. And people who want an electric ferry because it's going to save them money are doing it for the wrong reason, because it's not a get-rich-quick scheme, but it can stack up, and it is a responsible investment, and it's an important and powerful climate action.
Is there a future where EV Maritime gets into offshore support vessels or other types of electric vessels, do you think? Or do you think the electric ferry market's deep enough that will, that's the next 10, 20 years?
It's really hard to know. We're certainly open to it. I mean, we're not EV Ferries, we're EV Maritime. We're about decarbonising the inshore commercial maritime industry. But ferries is a really good first place to start, and there's kind of 2 or 3 really core reasons for that. One of the things about urban public transport ferries is that they don't typically go all that far. You know, your journeys are anywhere between 10 minutes and an hour long in almost every city in the world, and they come and go from the same docks every time, so you can charge up at both ends. And so, you know, when you're dealing with very large amounts of energy, as is the case with fast ferries, you're not talking about boats that charge all night and run all day. You're talking about boats which charge regularly through the day. And ferries are a great candidate for that because they come and go from those same places time and time again through the day. So that's one really good reason why ferries are a good sort of stepping off point for this. Another reason is that they're extremely energy intensive. You know, a fast ferry in a busy public transport system can be running up to about 5,000 operating hours a year. That's a really busy boat, even in a hardcore commercial setting. And if you're running 5,000 hours a year in a fast ferry, which the way you go fast is by throwing lots of horsepower at stuff, you're using a lot of diesel. And so, you know, one diesel boat of the size of the boats that we're doing will use something up to about 750,000 litres of diesel a year for about 2,000 tonnes of carbon emissions. That's a vast amount of energy. And so it's a really powerful place to put those first efforts as well, because compared to most other commercial boats, at least in the inshore space, they're burning more fuel. From an economic perspective, of course, because you're displacing a very large amount of fuel relative to the size of the vessel, the economics stack up a whole lot better. It's quite hard to make the economics work if you say, I'm going to run a boat twice a day. I'm going to start in town and I'm going to run a shuttle out to a offshore facility, and I'm going to sit there all day long, and then I'm going to run the shuttle from the offshore facility back into town with the staff on it at the end of the day. That asset costs you just as much as the electric ferry cost you to build, but instead of running 50 trips a day, it's running, or maybe 15 or 20 trips a day, it's running 2. And so the economics of making that investment stack up are much more challenging.
Like there's a capex cost that's similar.
It's the same anyway.
The advantage is only being used twice a day. You're not using it enough to get the benefit.
Yeah.
Okay.
But that's going to change over time. You know, we certainly see demand for zero emission ferries in the oil and gas sector and in the offshore wind sector, and so that's, you know, there is it doesn't, you know, that comes to my point that it doesn't always have to stack up financially. It's much easier to get these things over the line if it does. But sometimes you've got a big energy company that really wants to electrify what it can because it's part of maintaining social license to operate.
It's an input emission. They've got to make sure they minimize it to make their product make sense. You mentioned having. Do you think you're going to need fast DC chargers everywhere? I think people that maybe are familiar with charging a car's battery don't quite understand the volume of extra that you're doing with a big vessel.
Yeah, it's quite big. You know, typically your biggest car chargers around the world at the moment are in the order of about 300 kilowatts, and the chargers which are being rolled out here in Auckland for the fast ferry network are 3 megawatts. So they're 10 times the size. And there's a couple of places around the world we've seen, and Bangkok's one of the better known examples that's running electric ferries that have just a great big huge lineup of automotive chargers with all these cables going across and plugged into them. Right. That's not the way we're going. We're running to high powered chargers. It's custom installations. You'll end up with for want of a better word, a Bowser down on the floating dock. But that'll be supported by something the size of a 40-foot container up on the dock that's got all the power electronics and whatever to support it. So it's big gear, it's expensive. But for those people who say, oh gosh, that's just too hard, my message is Well, it's hard because it's worthwhile. It's hard because that's the amount of energy that's currently being made out of diesel.
Yeah.
So that's why
and
this matters.
they're also not. It's also not like refueling. If you are refueling a diesel ferry, it's not like refueling your car at the gas station where you kind of go in and a few minutes later you're done.
Oh yeah, but it is. I mean, in the Auckland transport network, we're looking at charging it between 2 and 3 megawatts, depending on the boat. They will typically be charging for between 5 and 10 minutes each time you plug in. And they're charging while they're loading and unloading passengers. In some cases, they're doing a number of back-to-back trips before they plug in and recharge, but mostly, at least in the mid-harbour routes, they're going to be charging between every service, and crew operations are going to get a little bit like a pit crew in a Formula One team. You've got your order of things, and you tie the boat up, and you plug the boat in, and you let your passengers off, and you board your next set of passengers. And
automation around the charging. There are a few automated kind of mooring and charging solutions out there, or do you think
there's some really good ones? We're not at the moment, and the simple reason is to do with vessel standardization. So if we were in a position where we could standardize the vessel across the whole network, then you could get to the point where you could do it. But at the moment, Auckland has a reasonably complex ferry system where there's some boats that run to a large residential island, quite popular with tourists. They need to be much bigger boats. They can be electrified too, and so but they're 2-story boats, and they've got 400 people on them, not 200 people, and so being able to charge those boats and the smaller boats from the same infrastructure is an important part of the system design. And even though those future boats, those 400 passenger boats don't even exist yet, they will absolutely be going zero emission. So how do you charge those up? So until you can get to a point where you can standardize, there's compromises to most of the robotic systems. The whole thing is about how it's not about safety, because it's safe to plug these in. The onset of MCS, the megawatt charging standard, means that you're only going to be plugging 2 plugs in, even if you're charging at 3 or 4 megawatts. And so you're not having to plug lots and lots and lots of plugs in all the time. There are definitely automated solutions which will be good, but I think that the reason why the automated stuff took off in the last sort of 5 years or so was actually because there was no viable plug solution for the amounts of energy involved.
Right.
I think that there's a block of boats in the middle that probably don't need it, because invariably with most of these systems, you're then carrying around heavier equipment on board the boats as well. So it's a complex system, but
and there's more things to break down, right? You've got another thing that if it breaks, you can't charge and can't run your ferries. Does EV Maritime get involved in the system design with the client for things like that?
Very much so. Yeah, we do. I mean, in the case of the Auckland project, we're involved actually kind of, if you like, client side. So we're consulting to Auckland Transport on their physical infrastructure requirements, and then we're collaborating with their selected providers of that as one of the providers of boats. We're collaborating from that perspective as well. So, but yes, I mean, we get very involved, I guess, through both lenses. We do a lot of energy modeling. We do a lot of thinking about what that charging infrastructure needs to be, because it's just the opposite side of the boat. But we're at least in the case of the Auckland project, we're working with AT's selected providers who are then doing all of that. It's a big civil works project, really.
I did want to ask about, you mentioned big vessels, small vessels. One of the interesting things, I'm obviously interested in hydrofoils at the moment in what I'm looking at, and with the EVM 200, there's a foil assist option, which, can you just explain what that is to people that maybe haven't heard of it? And why would you bother doing it, and why would you not fully hydrofoil?
Okay, right. So just to back up the cars a little bit, these are catamaran ferries. So they've got 2 hulls, and what a hydrofoil assist means is there's a hydrofoil, like a wing, that runs between the hulls underwater, as far underwater as we can make it, and it picks up a proportion of the weight of the boat in hydrodynamic lift as you go along, and you can adjust the angle of attack of that foil to adjust how much lift you generate. And we're picking up about 20% of the weight of the boat with that foil, which is a pretty good optimum in terms of the overall drag picture until you want to go fully foiling. So we offer that hydrofoil assist as an option in the sense that the boat doesn't need it. It only adds about another knot or so of top speed, but it saves 7 or 8% of the fuel burn of the boat at any given speed, at least any given speed that you're interested in. And so what that means is you use 7 or 8% less energy on a run, which means you spend less time recharging, which makes it easier to maintain schedule. You have more uptime. So from that point of view, that's what it's about. But we have some customers who don't want hydrofoils. And so what we were particularly pleased about was, in our case, Auckland Transport isn't closely familiar with foil assist boats. There actually are some foil assist boats operating in the Auckland Transport fleet, but it's one particular operator, and we know those guys really well, and they swear by those boats. They're terrific. But some of the other operators, I guess, hadn't operated boats with hydrofoils, and various people were concerned about what if there's flotsam in the water and so on. So actually, we've got the opportunity where we are building one boat with a foil and one boat without a foil. Now they're both boats are going to be built identically, so they'll both be built to receive a foil, but only one of them is going to have one fitted initially. So that'll be great to enable us to really validate.
Real world validation, not just
real world validation. Yeah. So we're really looking forward to that as engineers and scientists. That's a rare opportunity. Why aren't we fully foiling? Well, and by fully foiling, you're talking about having foils which hang down below the bottom of the boat, and which when you go fast enough and apply enough lift, you lift the boat clear of the water, and it's only those foils that are down in the water. And a couple of issues that you have. We have a relatively shallow harbour here in Auckland, and there are many places where these boats go where there isn't enough draft to. You'd have to stay on the foils as you went over the shallow bits, and any seaman will tell you they're not going to do that. So you have to have retractable foils. You can do that. There are people doing retractable foils, but it adds cost and weight and complexity. But more than that, the way Auckland Harbour works is that there are, like most harbours, there are low-speed parts and high-speed parts of the river, of the harbour. And when you're, quite a lot of the time that is spent on any given journey is actually spent at low speed, and the amount of time spent at high speed is not all that long. And so, you might only, if you could take a boat that was doing 25 knots and you make it do 30 knots, and even on some of those longer trips, it might only add 3 or 4 minutes take 3 or 4 minutes off the journey time of the. And so from a customer service perspective, you've got to go an awful lot faster to make any material difference to the transit times that you're offering your customers. And then to the point that you say, well, how fast is it safe to go in a busy harbour? And so there are definitely routes in Auckland where it's perfectly safe to go really fast for some of the journey. But what we found is that with the boats that we were focusing on at the speeds that we were wanting to maintain from the existing fleet, fully hydrofoiling didn't offer any particular drag benefit at the size that we're talking about. If we were doing small boats, we were doing boats that only needed to take 20 or 30 or even 50 passengers, then at that speed there definitely would be a benefit. But when you're carrying 200 passengers, the crossover point was around about that 23 knots, which is around about where we are anyway in most of the service.
Yeah.
So it just wasn't of benefit.
I do wonder if there's kind of offshore routes, and I'm thinking of Sydney Harbour, which is my local harbour. I do wonder if you had the ability to go fully foiling, if you were a bit faster, if you could guarantee the customer comfort in moderate seas, if there might not be routes that would leave the safety of the harbour and go to another harbour a little bit further up, further north or further south. For us, that would, I imagine that might be interesting. It's definitely not something people are currently thinking of, because the routes at the moment are not comfortable. Going out through Sydney Heads, going across Sydney Heads, which is the big man ferries do. There's lots of videos online. You can see them on YouTube, full of people getting kind of tossed around.
Sure. Done the trip plenty of times. Yep.
Yeah. Do you think that's a possibility, or do you think it's a bit too remote?
Oh, yeah, no, totally, it's a possibility. And one of the things that enables hydrofoils to do the type of thing that you're talking about is clever automation and high speed computing. That boats are in those sorts of conditions, when you're in sort of ocean waves, they're quite large waves, and if you just carried on straight, then you'd have to have your hydrofoils an awfully long way below the water. That's not actually what's going to happen. You'll go up and over those waves and down again, and follow them.
Movement. It won't be flat.
It won't be dead flat, but not in those sort of ocean swells. But yeah, absolutely, it'll offer some benefit from a comfort point of view, and I guess everybody's got to choose their niche and work out where to work. And for us, we're very focused on making cities better and on reliable public transport to get people out of cars. Now, what you're talking about is another way of doing that same thing, because if you can serve the northern beaches better with public transport, then maybe people will take the ferry instead of taking their car. I guess you just got to look, and I don't know the conditions well enough to know whether it's
there's not many harbours on the northern beaches.
What conditions you can run in.
It's full of beach.
That's right.
Beaches and cliffs is pretty much all it has. So and then Pittwater's far enough up that while it's nice to drive around on a boat, it's probably just faster to get on a bus and take it up there. I wanted to ask a little bit about I have an interest in alternate fuels and hybrid vessels. Do you see any need for that in the ferry space? Is there any kind of part of EV Maritime that's going, well, sometimes we need to have maybe we'll have fuel cells, hydrogen fuel cells, which some people are using, and they're using the America's Cup for the chase boats. Do you see anything like that coming in the future, or do you think it's that actually electric is just going to keep getting better and better, battery density will get better, and so we won't?
Yes and yes. I think that batteries will continue to improve. We'll get more and more range out of battery boats, but absolutely, there's going to be a role for alternative fuels in terms of things like hydrogen. Hydrogen fuel cells is a pretty attractive option. It's, as far as the use of hydrogen goes, it's reasonably efficient. And for a boat of the same weight as ours, if we were to make it into a hydrogen powered boat and get it to do the same amount of work in a given day, then instead of charging up 10 or 20 times a day, it could run all day long with a single fill of hydrogen. But it will still end up being the same weight boat. And if you don't want it to be that heavy and you want to save a whole lot of weight, then you need to get into refueling it multiple times a day. And that's fine as well. You can do that. But refueling hydrogen is not trivial any more than anything else is. And so, but yeah, I think we'll see hydrogen playing a really big role. I don't think it'll have any significant role in, for example, Sydney Harbour or the Brisbane River. Or in Auckland's inner and mid harbour, possibly in some of the outer harbour routes. Well, we have a route here called Gulf Harbour, which is about twice as far as Circular Quay to Manly, and it's a reasonably open stretch of water, and And if you can run that full electric. Our boats will get out there just fine, but they've got to recharge for sort of 25 minutes before you run again. And if you do that, then you effectively need an extra boat just to make up for that boat that's sitting alongside charging. And so that's quite expensive. So the economic prospect of having a smaller number of boats with a accordingly smaller number of crew that could run all day long like they do with a current diesel boat, pretty attractive. And I think that in Australia, places like the Great Barrier Reef are a really good example of a place where hydrogen, I think, is going to play a really big role, because the distances are quite large. Taking tourist excursions out to the reef, there's no sustainable source of electricity out there, not in the amounts that are needed to charge up a ferry. So hydrogen, I think, is going to play quite a role.
Yeah, people definitely aren't going to want to take the beautiful islands and cover them in solar panels or put huge wind turbines out there. So I think you're right. There needs to be something in that area. Is Auckland the first place we're going to see EV Maritime's ferries kind of running? Do you have any that are in operation already? I guess
we don't. No, the first ones that we're going to see running are the ones that are in build at the moment. So we've got two 200 passenger carbon fiber battery electric ferries in build for Auckland Transport. They started building last year. They're going to finish building next year. First one launches in about the middle of 2024, and then we'll see those on variously going through commissioning and sea trials and crew training, and eventually we'll see them in real public transport service from probably early 2025 is the current projection.
Yeah. Okay. Excellent. And this is an area I'm like, obviously I'm looking at the wide span of people out there doing electric ferries. There's a lot of competition for EV Maritime amongst that group. How do you think you're going to differentiate EV Maritime from other electric ferry providers?
Well, I think there's a few ways. I think that for starters, we're not just a designer and we're not a shipyard. So we're a designer and system integrator. So our job is to help boat builders around the world become electric boat builders. We're not trying to fill up space at any one particular shipyard. Our role is to work with shipyards everywhere around the world. So for us, that's not just an economic opportunity. That's another sort of social sustainability story, really, in terms of enabling local jobs and helping local industry around the world to transition. So that's definitely a big part of it. From a product point of view, there's a little bit. I mean, there's not. I think that one of the things that we and one or two others are doing is that's a major differentiator is standardization. And the industry thinks we're a bit crazy because the industry is built around the idea that every boat is somehow different and unique and different and special. The data just doesn't support that. The fact is, when you're looking at urban public transport ferries all over the world, there's an enormous convergence of requirements towards particular speeds, particular distances, particular sizes, particular passenger capacities. And if you're a public transport authority or an operator embarking on this brave new world of electrification, risk is at the top of your mind. And you really don't want to embark on yet another custom project with a whole lot of people reinventing the wheel, because and I know this firsthand, these are really expensive projects. The design and development process in this is very long and time consuming, and yet the improvements that you make to the design as a result of spending all of that time are very real. And so the simple reality is the standardized boats are going to be the better boats. They're going to be the cheaper boats. They're going to be the more reliable boats. And they're going to be the boats that banks and insurance companies and operators and public transport authorities have the most confidence in. And ultimately, that confidence is vital to catalyze this transition, because without it, we're going to continue to see people, as we've seen with Transport for New South Wales, building diesel boats. And they have to stop.
Yeah, definitely. Absolutely. Well, thank you for your time, Michael. Have a great afternoon. and look forward to seeing what EV Maritime does in the future.
Thanks, Angus. Nice talking to you.
Thank you.
See ya.